Good morning, children. Welcome to Government Group of Schools online classes. Today, you are going to learn about Newton's third law of motion. Yesterday, what you have learned? Yesterday, we learned about Newton's second law of motion, and in that, you are getting a concept as momentum. So, what is momentum? Momentum is nothing but a product of mass and velocity. And here, Newton, what he has given here, what he has expressed, any object which is having mass, every object will have mass. When the object is moving, it will have a velocity. So, mass in motion is said to be momentum. So, yesterday you learned about momentum. And what Newton's second law explains here is force applied is directly proportional to rate of change of momentum. So, today we are going to learn about Newton's third law of motion. Here, Newton's third law, what it explains here is when one object applies force on another object, what happens for the another object here. So, here for that we are taking two spring balances here. One spring balance both having equal calibration and both are getting connected in this manner, and you are applying the force on opposite directions here. So, you are holding one spring balance on this side, another spring balance on the another corner, and you are able to apply force in opposite direction. Then, if you observe the readings, what you are able to get here, the readings in this first balance, we are able to get here as F1, here the reading is F2 here. So if you observe here, the values are equal. So the force F1 is equal to force F2 here. So that is nothing but whenever you are applying the force on the objects here, they are getting equal here. So this is said to be action, another is said to be reaction. But if you observe, this direction is in opposite direction, so that the magnitude of force is equal, but direction is opposite. For the sake, here you have to use a negative sign. So F1 is equal to minus F2 here. Similarly, whenever an object A collides with another object B, what happens here? This A object applies a force on B object, that is equal to FAB here. And B object applies force on A object, that is FBA. So, whenever both objects are getting collided, the force applied by first object on second object is equal to the force applied by the second object on the first object. So, the magnitude of force is equal, but the direction is opposite. So, from this what you can understand, any object whenever applies force on another object also applies equal force on the first object in opposite direction, but the magnitude of force is equal. So that proves Newton's third law of motion here. So for every action, there will be equal and opposite reaction. So that is said to be Newton's third law of motion. For that, we have different examples here. Suppose if I apply a force on the board like this here. So, board also applies opposite force on my hand here. So, both forces are equal, but the direction is opposite. You have another example, when you are walking on the ground, you are placing your feet on the ground in this manner. You are applying a force on the ground from your feet here. And ground applies opposite force on our feet, so that you are able to walk freely there. So, these forces, two opposing forces are said to be the action and reaction pair. So, one is said to be action, another is said to be reaction. So, for every action, there will be equal and opposite reaction. If you consider in this example, here FAB, the force applied by A on B is equal to the force applied by B object on A, but in opposite direction. So, this is said to be action, that is equal to minus reaction. So, for every action, there will be equal and opposite reaction, that was explained in Newton's third law of motion. So, we have different examples here. In this, when a bird flies in the sky here, so it will flatten its wings here. Whenever it is flattering its wings, the wing pushes the air downward direction and the air pushes the bird in the upward direction, so that the bird can fly to greater heights here. So the wings will push the air downwards here. That is called action, and the air pushes the bird in a upward direction. That is said to be reaction. So for every action there is a opposite. So for Newton's third law, you have an example. A bird is flying in the sky. In that the bird will flatten the wings so that it pushes the air downward direction, so that the air pushes the bird to upward direction. So the bird can fly to greater heights here. Here the wings pushes the air in downward direction, that is said to be action, and the air pushes the bird in the upward direction, that is said to be reaction here. You have another example here, that is nothing but here rocket. The principle of working of rocket also comes under Newton's third law of motion here. So whenever the fuel is getting ejected a very force, then that is said to be action. Due to that, the reaction force makes the rocket to move in a upward direction. So this is said to be the action, so that the gases are ejected through the nozzle with greater force here. That is said to be the action. Due to that force, the rocket moves with a higher velocity. That is said to be reaction. So for every action there is a opposite and equal reaction. So that is said to be the Newton's third law. You have other examples. Whenever a fish swims in the water, it pushes the water through its wings in backward direction, so that water pushes the fish in a forward direction, so that the fish can able to move forward in the water. It is able to swim in the water. In the same way, when we are swimming in water also, we will push the hands, the water in backward direction, so that the water from the back onwards it pushes the person in the forward direction. So that is an action and reaction force acting on two different objects. What we are understanding here is in Newton's first law and second law, that force is acting on a single object here, on the single body. But in Newton's third law, this forces, action and reaction forces, are acting on two different objects here. So these are all some of the examples for Newton's third law of motion here. So you have one more activity that is said to be balloon rocket activity here. So basing on Newton's third law, you have an example called balloon rocket. In this, first you have to inflate the balloon with air, and you have to hold with your fingers its neck here, and you have to take one straw. In that you have to insert a thread, and you place the balloon on the straw, and by using the tape you fix the balloon, and whenever you leave it, the balloon, this air escapes from the balloon, so that the balloon moves forward like a rocket. That is said to be balloon rocket here. So in this, what happens here, whenever you blow air inside the balloon, that air applies the force in all directions on the walls of the balloon, and whenever you remove your fingers, the air escapes out with greater velocity, so that here, whenever the air is getting escaped, remaining part of the air which is applying the force on the balloon walls, it makes the balloon to move forward here. So that air, whenever it is escaping outside, it will have momentum here. To balance that momentum, this balloon moves in a forward direction. So this is one of the best examples of the Newton's third law of motion. That is said to be an activity called balloon rocket activity. So this you are able to see in the chart in this manner. So here, this is a balloon, and the balloon is inflated, and it is placed on the straw, which is getting connected with a thread here. You have to ask your friends to hold the thread on either side, and you have to just release your fingers. Whenever this air is getting escaped outside, the balloon moves forward like that of a rocket. This is said to be the balloon rocket. So now we are able to see the activity. So this is an inflated balloon. I placed it on the straw, and it is taped here with cellophane tape. And when I release my fingers, the balloon starts moving forward. This is how this works in the principle of here Newton's third law of motion. So that is said to be a balloon rocket experiment here. Similarly, you have a rifle in that when you are placing a bullet and if you fire it, the bullet will move with a high force with a greater velocity, so that to recoil its momentum, this back part of that rifle will move backwards here. So this is the bullet moving forward is said to be action, and the reaction is nothing but recoil of the gun. The gun moves backward. So that is said to be recoil force of the gun. So this also comes under the principle of Newton's third law of motion.